Hello, and welcome to this film, which is all about ions. Now, in recent times, we've been looking at isotopes and atoms, and we've been looking at how we can use symbols to find out things about those things. Here, we're going to try and understand what exactly an ion is. And once again, we're going to try and reinforce this stuff that we've been doing about symbols and subatomic particles. We're going to try and figure out how many protons, neutrons, and electrons there are in some ions by looking at some symbols. Now, before we do that, let's just remind ourselves of what we said about subatomic particles, and in particular about their charge. So we said when we were looking at these things that protons have a charge of +1 and electrons have a charge of -1. And we also said that in atoms in the periodic table, in neutral atoms, so atoms that don't have an overall charge, the number of protons and electrons must be the same. Okay, because the pluses are cancelling out the minuses and giving us no charge overall. That's what we mean by neutral. But in an ion, and here comes quite an important definition, there's an imbalance of charge, and that comes about because atoms lose or gain electrons in chemical reactions. Okay, so an ion is a particle that has an imbalance of charge as a result of an atom losing or gaining electrons. Now you might think, well, atoms could lose or gain protons, couldn't they? And that would give us an imbalance of charge. Yes, but not in chemical reactions. So here's a diagram that's trying to show us what's going on in one particular chemical reaction, but it's common to all chemical reactions that involve exchange of electrons. Okay, so here we've got a sodium atom, and this diagram is trying to show us the electron configuration of a sodium atom. Here's an electron that's in its outer shell. It's actually being given here to this chlorine atom. And we can see this electron turning up here. And what we can also see maybe here is that the sodium atom has now got a little plus charge next to it. And the chlorine atom appears to have got a little minus charge. Okay, so chemical reactions involve electrons either being gained or lost or shared between atoms. And this is going to result in particles that have an imbalance of charge. Now, when atoms lose electrons, what's going to happen? Well, all of a sudden, we're going to have more protons than we do electrons because they start off equal. And if we've got more positive charge than we do of negative charge, then we're going to form positive ions. So any time an atom loses electrons, we get a positive ion out at the end. If an atom gains electrons, well, all of a sudden, the number of protons and electrons won't be equal anymore. In fact, there'll be more electrons, so there'll be more of the negatively charged particles here. They will outweigh the positives, and so we'll get negative ions as a result of gaining electrons. And this is quite confusing for some people because sometimes people think, oh, I guess if something gains something, it's going to be positive, but it's gaining a negative thing, so it becomes negative. Here's a few quick questions, as usual, for you to test yourself and to see how you're going. And here's the answers. Remember, pause the film and go back if you need to, if you're not understanding here. Now let's have a look at a couple of example problems together. Okay, so now we've got this symbol here, Mg2+. We've got to find the number of protons. It's very difficult to do a problem like this without a periodic table, but if we looked in the periodic table, we would see that the atomic number of magnesium is 12 and the mass number is 24. What's the number of protons? Well, that's given by the atomic number, so 12. What's the number of neutrons? Doesn't have to be the same as the number of protons, remember, but this is found by taking the atomic number away from the mass number, and in this case it would give us the same number, but that's just a coincidence. Okay, 24 minus 12 equals 12, so there's 12 neutrons. How many electrons are there? Well, they'd usually be the same as the number of protons, which would be 12. But this symbol here is telling us that this atom is not neutral. It's got a charge overall. It's got a positive charge overall. What does that mean? It's lost electrons because electrons are negative. We're left with more protons. How many electrons has it lost? Must have lost 2 because there's 2 pluses. So the number of electrons would have been 12, but it's lost 2, and so it's 10. Let's have a look at another one. Here we've got something called a nitride ion. So this is nitrogen, and it's got a 3- charge. Again, difficult to do if you don't have a periodic table. So use the one in your data booklet while you're doing this. Find the number of protons. How do we do that? Well, we look up the atomic number. Okay, that's the smaller number in the periodic table, but remember when we're writing it by hand, it always goes bottom left, so 7 protons. Number of neutrons, well, the mass number of nitrogen in our periodic table is 14. 14 minus 7, that's 7, because we take the small one away from the big one to find the number of neutrons. In both these examples we've seen, they've been the same as the number of protons, but that is not a rule. It doesn't have to be that way. The number of electrons, well, we've got to use the charge for that. It's not a neutral atom, so it's not the same as the number of protons. In fact, it's negative, so that means it's gained electrons, right? And it's gained 3 of them, so it normally have 7, it's now got 10. Hopefully those things make sense, but if not, watch it again and check that you can understand. Make sure you've got your periodic table while you do it. Again, here's some quick questions. You'll need a periodic table because you probably don't remember the atomic numbers and mass numbers yet. And here are the answers with a bit of explanation. Now, in this film, we were trying to understand exactly what an ion is. Hopefully you've got a definition for that written down. And you can use symbols that now include charges to decide how many protons, neutrons, and electrons there are in an ion. Really important, as usual. If any of this doesn't make sense, please go and ask your teacher as soon as you can, because you want to be able to move on feeling confident about the stuff that you've done so far.